Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. We have been covering the statistics paper 3, which is of descriptive type, and the topic which we have been covering from the previous video is time series. In time series, we have covered the measurement of trend, and now we have moved on to the measurement of seasonal variations. In this, the third method is ratio to moving average method. In the first method was simple average method, which we have done, and the second method was ratio to trend method, which is also covered in the previous lecture. In today's class, we'll move forward to ratio to moving average method. So let us begin. We'll do it similarly as we did the previous two. We'll first write the steps, then we'll take an example, and then merits and demerits of the method. So ratio to moving average method. What does ratio to moving average method step says? So first is compute the yearly, 4 quarterly, or we will say 12 monthly moving average. So first of all, we'll compute the moving average, which consists of trend values plus cyclical variations. Then the second step would be compute the centered moving average since we have given the 12 monthly moving average. These may or may not be centered. So if they are not centered, then in the second step we'll compute the centered moving average. In the third step, we'll find the, or we can say express the centered moving average. I express the original data as percentage of centered moving average. So here trend and cyclical value will be diminished, and the fourth point would be express, and we'll get seasonal variations, express seasonal indices by averaging, and this removes. Now here we had all the parts: trend, cyclical, seasonal, plus irregular, or RT, random component. Here we have removed trend and cyclical, so we are left with seasonal and random. And here we have expressed the seasonal indices by averaging, so we have removed random component and we are left with seasonal, which was our purpose, to find seasonal. So let us take an example. A data has been given for 4 years, 2001, 2 and 3, for 4 quarters. So let us make the chart. These are quarters. So we have been given year 2002, 2001, and quarters, 4 quarters of each year. Quarter 1, quarter 2, quarter 3, quarter 4. 2001 to quarter 1, quarter 2, quarter 3, quarter 4. 2003, quarter 1, quarter 2, quarter 3, quarter 4. And 2004, quarter 1, quarter 2, quarter 3, and quarter 4. So there has been 16 values, and the 16 values are 75, 60, 54, 59, 86, 65, 63, 80, 90, 72, 66, 85. So these are the values of yi, or the demand. Okay, so first of all, we'll calculate the moving average of these. So moving average of these would be not 12 yearly but of 4 yearly, because we have been given the quarter. So we'll calculate moving average. So the first moving average would be from 1, 2, 3, 4. The moving average total. Then centered moving average total. Then moving average average. So the average of these four values would be 248. We'll skip 2 from above and 2 from below. And from here we'll start writing. We have discussed this. How do we calculate moving average? If you don't know the concept, then you can rewatch the moving average video. I have discussed in detail there. I'm not discussing it here. So the moving average are 248, 256, and 264, 273, and so on. I'm not writing all of them. Okay, so here we see that these values lies in between the values. So these are not centered values. And the total that we'll get is 13. So it is an odd number, so we'll calculate the centered moving average. So centered would be the average of these two, 248 plus 256 upon 2, which will nothing but 507, and this will be at the center of these two value, which is against this third value. So this is how centered moving average is calculated. It will be 523, 6, 27, and so on. This is how we calculate the moving average total. Now we'll calculate 4 quarter moving average. This is moving average, because we are calculating for quarterly data. So we'll divide this. If this column says this column is column number 5, so we'll divide 5 by 4. If it would have been yearly data, then we would have divided it by 12. So dividing this by 4, we'll get 4 ones are 4, 10, 4 twos are 8, and 4 twos are 8, 27, 4 4 sevens are 28, 4 6 are 24, 126.75, something like this we'll get. 126.75. And so on, we'll divide the other averages. So this is how we calculate the moving average. Now ratio to moving average method is nothing but, if we divide this, if we divide 2, now we have to calculate the percentage method. This as a percentage of the original value. So here we'll divide it by 8. So here ratio to moving average method, for ratio to moving average method, we'll take the original value, which is 54, and we'll divide it by this moving average value 63.75, and we'll represent it as a percentage of it. So the answer that will come would be 85.207, and rest all values you can calculate. So the final values, suppose the chart is given like this. This is for quarter 1, quarter 2, quarter 3, quarter 4. And this is for 2001, 2002, 2003, and 2004. So these two values and these two values are not given. So first value which came out was 85.207, and suppose this is x1, x2, x3, and so on. Some values have been given here. So we'll calculate the total of these values. First of all, we'll calculate the total here. Suppose here it has been 4, here it has been 5, and here it has been 9. So the total would be 18. Suppose here it is y1, here it is y2, and here it is y3. So these are the total of the values. Then we'll find the average of these values. So 18 divided by 1, 2, 3, and 4. So 18 divided by 4 would be 4.5. And similarly it would be z1, z2, and z3. So these z1 plus z2 plus z3 plus 4.5 should be equal to 400. If they are not equal to 400, then we suppose they are coming as 398.75. So we'll divide 400 by this number 398.75, and we'll get a value k, and we'll then multiply this k which each of these which with each of these numbers here, and that would be our final answer for the calculations. So this is how we solve ratio to moving average method. It is very much similar to ratio to trend method. The only difference is there we used to find trend, and here there we used to fit the trend value by principle of least square, and here we are finding by moving average. Okay. So now this method has merits and demerits. What are the merits? This is most widely used method. This is flexible method. and it removes all other components like trend, cyclical, and random component, and we are only left with seasonal. So there are some demerits also, that there are loss of values. For 12 yearly data, for 4 yearly data, we have lost 4 values. For 12 yearly data, we lost 6 in the from the starting year, and 6 from the ending year, at the end of the ending year. So we'll lose almost 12 values, which holds a very greater place uh, in our calculation, and hence this is the demerit of this method. So I hope that whatever we have done in class has been understood by all of you. If not, then you can ask in the comment section or on our WhatsApp channel. Anywhere we would be happy replying to your answers. Only valid questions would be replied. And for this method, many examples have been given from the online you can take, or from FAS, Fundamental of Applied Statistics. You can practice these kinds of questions. And tomorrow, this seasonal variation in the next lecture would be over, and we'll move forward to cyclical variation. So, all the best and thank you.